the blade. And third thing, nacelle. Nacelle is kind of a room which is placed on top of the tower where you have the entire generator and the electrical products that is set inside the room. That is called as nacelle. And next we have the rotor and hub. Hub is the nose point of the tower when you face it in the center. And finally we have the most important part, that is the blades. This looks very simple with the words, but when we look into the images, it is somewhat like this. This is how a foundation looks like when they are built. You know how complex it is building a foundation. A turbine might look very simple when we look through an highway or look through a site, just a big fan rotating like, oh, nice. But these many processes are carry forwarded in the behind thing so that the turbine stays for 20 years, 30 years. And this is the nacelle part and the hub part. And this is an image of a blade attachment which being installed in any site. So next, when we come out about the wind turbines, there are mainly two types of turbines classified on where it is located. First one is onshore turbines. Onshore turbines is nothing but the turbines that are placed on the land. That is what you see anywhere in India, because in India we don't have turbines placed anywhere else other than land. This is how it looks like. But we do have another option, which is offshore turbines, where the turbine is placed in the water. I mean, on the surface of water. I know that would be that would raise to many questions like how is it possible, how the electricity is passed through, or how it is even possible. So many people would be like, oh, there's a turbine on the surface of water. Like, we would see how it works there. All the components are assembled on site, that is out of the sea, including the blade assembly, including the hub, including the nacelle and the tower. Later, the installation vessel that acts like a crane, which is set on the surface of water so that it helps in the complete setup, like from the tower to nacelle and blade. And yeah, substation will be located out of the sea within the site. You know, the electricity that is generated through the turbine should be passed through the substation. So you can't have the substation in the water or on the surface of water. So that should be away from the water, but within the site. This is how an installation vessel looks like when we have a graphical diagram. This particular setup is made on the surface of water so that it is very helpful while setting up the tower and the blade with the complete setup working on it. So there are a few conditions which should be followed when a turbine is made to set up on the water. That is, a turbine should be at least 10 kilometers away from the shore. That is, when you have the shore, no turbine should be kept within 10 kilometers. And that shouldn't be more than 30 kilometers also. And there is another point that the sea depth should not be greater than 40 meters. These three things are followed when a turbine is set up in the water. So you all be thinking like, fine, this is all okay, but then how to set up a wind turbine? Like, how does it even start, or how does it even look like when it finished? Everyone asks this question. So when we come up with the steps that are followed when to set up a wind turbine is, first thing that comes is design. Without the design, nothing is going to there. First thing, the customer requirement. Few customers will require the wind turbines according to their requirement, like I need these accessories fixed on the turbine, I need this color, and I need this distance, that is, I need this long. All this will be designed there itself. And then it goes for the component fabrication. And then it goes for the tower construction. And then finally, with the customer requirement, the blade manufacturing will take place. And then even the nacelle assembly will take place. Keeping all this, the main thing which participates in the tower or in the wind turbine setup is transportation and installation. This looks very layman word, transportation and installation, but this particular step is very, very important while setting up an wind turbine in any site or in any country, because manufacturing a wind turbine is very easy in the industry. Setting up the wind turbine in the site is also kind of easy, but taking the wind turbine blade from the manufacturing unit to the site is very, very difficult. So that is the reason I'm telling you this particular step, transportation and installation, plays a very major role while setting up a wind turbine. And after setting up all this, testing and commissioning, this should be happening, because after setting up a wind turbine should work as expected. The data should be received as expected. There shouldn't be any error. There shouldn't be any glitch. So, and then if it all goes with a green signal, this would be the final step, that is ongoing maintenance. That would be periodical setup, like quarterly. Again, the customer requirement. Few customer requires monthly maintenance and few customer requires quarterly and few requires even yearly ones. And that's where we all come into picture, maintaining the wind turbine inside view. So when we want to look into the wind turbine internally, so how does it look like an internal structure? This is how it looks like. And where you have the curved part, and yeah, this is exactly like an aircraft wind or an airfoil. So this is exactly where the curved shape, where you look, that side is a leading edge and the sharp edge this side is a trailing edge, and the complete structure is framed with the principle of sandwich method, where the laminate will be sandwiched with the upper surface and the lower surface, and in between you have the filler material. And in the blade you will be even have many accessories such as vertex generators and even serrations and even lightning receptors. Lightning receptors are the main thing that need to be kept on the wind turbine, where a turbine gets hit with a lightning strike. You don't see lightning strike hitting a wind turbine in India much, because we have a weather condition like that. But when you go to abroad like US, UK, there are very strong lightning strikes that directly hit the houses. You might be seeing in many videos. So in those conditions, when a lightning strike happens on the wind turbine, these receptors absorb the strike and transfers it to the ground. There are many cables internally going from the blade to the nacelle, and through the tower it directly goes to the ground. That's where the lightning strike being transferred directly to the ground. That does not affect any structural part of the blade. And if this is okay, then we would see the most important part that I was talking, transportation. How does it look? Many people, while you were traveling in the highway or somewhere, while you're traveling, you might have seen a big truck carrying one blade, where you will be having two escort vehicles front and back. They will be escorting the blade. No vehicle should be overtaking in those conditions. That's because that's the cost of a one blade. So no one should damage that. So here we have a sample image where one truck is being carrying a longest blade that is 77.6 meter in US. So this looks easier because there's no traffic here. But in India, when we look into highways, there are many trucks that are being carrying wind blades with us itself, that is with the traffic itself. So yeah, it is a bit challenging. And yeah, here is another image where there's a hub and the nacelle that's being carried forward to the site, and a Vestas nacelle that's being carried forward to the site with the proper. Hello, am I audible?
Yes, you are audible, sir.
Okay, so I didn't get any response
You
from
are
the.
audible.
Okay, fine. There's no any breakage with the voice.
Your voice is very
Yes,
nice.
sir, your voice is clear and audible.
Okay, okay, fine. Thank you. Thank you. Thanks for the confirmation. So yeah, going forward, uh, since these blades and towers and nacelles are very huge, see for example, if this nacelle looks like a 1 BHK room in Bangalore, so how does even all these components are lifted and kept up tower so that it works? This is how it is done. A big crane would be set up, and first thing the tower would be set, and then nacelle, and then hub, and then each blade would be locked with the crane and carried and fitted in the hub and made sure that there is no fault in the fitting, and then they go for the next blade. This is how each and every wind turbine are being set up. And here is a technician fitting one blade with a rotor. So if these images are very surprising or even very shocking, because no one knows how a wind turbine is set up and how a wind turbine is actually going, all the processes that is behind that we see in the site, that may be shocking. But then we do have much more shocking facts that many people will be having queries in their mind. Let me list out those. Yeah, one turbine of a 2-3 megawatt. That is usually, this is the common capacity that all the wind turbines will be having, like 2 to 3 megawatt wind turbine can produce 6 million kilowatt hours of electricity every year. That is, that particular capacity can give electricity to 1,500 houses. Yeah, and surprisingly, the common structure which we see from the outside has 8,000 different parts in it, which is very complicated. It looks very simple from the outside, but it has 8,000 different parts that is collaborated and combined together to look like a one wind turbine. And to get all these 8,000 with different parts combined together, the cost would be around $2 to $4 million, which we convert it to Indian rupees, that is around 16 crores to 32 crores. And average weight of the entire turbine will be 200 tons. This 200 tons is including the tower, nacelle, hub, and the blade. If we take blade alone, that would be around 35 tons, and following to the tower 70 tons and gearbox 55 tons approximately. This is the weight of one turbine, that is 200 tons. And when we come to the length of the blade, we have many length like 26 meters, 33 meters, and 77 meter and 62 meter. But when we look into the longest blade on land, we don't have the longest blade on water. When we do look for the longest blade on land, that is 131 meter in China. You know, this China is actively participating in the wind operations or in the wind energy sector from past 2 decades. Yeah, till date, they are being the most highly contributed country towards the wind sector. And when we come to the manufacturing time taken for one blade, that is usually 24 hours to 28 hours to manufacture one blade. I'm not talking about one wind turbine, one blade. So one wind turbine consists of 3 blades. So one blade takes almost 24 hours to 28 hours. But then, but then I'm again stressing on that. To manufacturing a blade, it takes 24 hours. But then to set up a complete turbine, that is from the installation vessel to complete turbine, it takes 5 days. So you can imagine the complexity that is carried forward behind the setup. So manufacturing is easy, but then taking the turbine to the site and setting up with the installation vessel is very, very difficult. And after all this, if a turbine is maintained very well, that is periodic maintenance, everything, if you get a defect and you get repaired, everything, a lifespan of a well-maintained turbine would be around 20 to 30 years. And when we come to the speed of a wind turbine, that is almost 30 to 60 revolution per minute. That is 30 to 60 revolution per minute would be very simple. The tip of the blade, that is where the sharp point ends, the speed of that tip would be around 100 to 200 miles per second. That is 350 kilometer per hour to 700 kilometer per hour. So we usually analyze all the turbines. So many times we see blood spots on the blade where it hits a bird or it hits some usually bird. So many blood spots would be found on the tip side. So that that speed it would be rotating. So giving information about these facts, we would talk about some energy perspective. What happens to energy? We have a wind turbine generator where it rotates and generates electricity. I mean, it keeps on rotating, it keeps on rotating, and the rotor gets connected to the generator and it generates electricity. Where does it go? It goes to a substation. Each and every site would have a substation. If it is a big site, they would be having even 2 to 3 substations where all the wind turbines would be connected internally so that the electricity from the wind turbine generator would directly go to the substation. And from the substation, it goes to grid. And from the grid, it comes to us, that is the user. And then the user can enjoy. This is what happens. Being said all this, we would talk about some analysis perspective. I was talking about the maintenance. So, okay, fine. A customer goes to a manufacturing unit, he tells his requirement, and then he builds a blade, takes it to the site, and after setting up everything, after all these efforts, one thing is pending, that is periodic maintenance. And that's where we come in. ZiteView. ZiteView is an inspection company where we analyze all the renewable energy resources with different verticals. For example, in the previous session, you would have got to know about solar. So I'm not going much deeper into that since you already had a knowledge on that. You talk about wind vertical, what we actually do. This is what we do. Globally, we have customers who has wind turbines across the world. They give their turbine to us to analyze periodically. Again, their requirement, monthly ones or 3 months or yearly ones or even half yearly ones. What we do is we have a team who goes to the site, they capture the turbine and we receive through that shared drives, and we have a portal called Wind Insights. We upload it to there and we have 4 stages in it where I have mentioned it: pre-screen, analysis, FQC, audit, and if required, special cases are being treated. These are the stages that are followed through the analysis. And if at all, we do promise our customer that if a severity 4 or 5, to give a better understanding, severity 4 or 5 is given to a defect or a damage on the wind turbine that is there, where if we notify to the customer that there is a severity 4 or severity 5 in that particular turbine, he needs to shut down the turbine immediately. That is, if that particular turbine goes on rotating again and again, there could be many chances of collapsing. That type of damage is called as severity 4 or severity 5 damage, and that is being intimated by us within 24 hours. I know these are the complexity that is being carried forward in the analysis section. So this is just because one reason. There have been many difficulties, challenges that are, and even money comes into the picture, that is being invested in setting up one turbine. So I don't think this is very difficult, because being all done, that setting up and money investing and time, everything, analyzing a turbine with this effort is not a big thing. And after complete analysis, report will be generated and given to the customer. So if at all, how a platform looks like how in what platform we do work is this. This is what our platform looks like. This is called Wind Insights platform that is created in our internal site view, where we have the complete details of the customer sites, number of turbines, number of analysis that is being carried forwarded, and number of analysis that is being carried forwarded from periodic, like quarterly, monthly, all the data we do have in this particular platform. And this is how exactly we have the data and we do analysis. We have the data, we do analysis each and every section. We make sure that we don't miss any meter of the blade. And if we find any defect on the blade, that would be marked. And we do have our own matrix so that the customer gets that matrix. And if a severity 1 to 5 is marked, he goes to that matrix and finds the defect and checks, okay, this is the damage that we have got in this turbine. And he approves, okay, this is the damage. This is how analysis is done. And post report submission, what does a customer does? That means if you give a report after analyzing, what can a customer do? He has two options. That is this. If you tell him that this particular turbine is having a crack or a damage, anything, a customer will be having two options. One is he might repair it that moment itself. That is, no, I am very concerned about my turbine, so I can't take risk. I'll repair it the next moment. That is possible. That is even the safest thing, because if I spend a 30 crores on one turbine, that would be my decision. If I find a small crack or a small damage, I would repair it. But there's another option which many global customers do: periodic observation. That is, if you find a crack in a turbine, the same turbine would be come for reanalysis after 1 month to check the same crack. That is, for example, if you find a crack that is 3 meters today, the same turbine with the new data would be receiving after 1 month to check the same crack, so that that particular crack would be 3 meter or it is elongated. If at all it is still 3 meter, that turbine goes for the next periodic checkup. But if there is an instance where that crack is elongated and there is 3 meter to 6 meter or 3 meter to 8 meter, then it goes for an instant repair. And while I was talking about the customers, we do have many customers, but there are three prime global customers that we have. They are G, Vestas, and Enercon. Apart from these three, we do have customers from Avangrid, Envision. Yeah. So, well, being all said, let's talk about some stats, like what wind energy is happening actually in the global level, or because these many efforts are being put together. So we should see what is it doing actually to the global sector. While we look into some stats, few surveys tell that in 2022, wind electricity generation increased by a record of 265 terawatt hour. That is 14% increased on the year 2022. As I said earlier, China is the most contributed to the wind sector, and following we have European Union, US, UK, everything. But then till date, China is being the topmost contributor for the wind energy sector. And if we talk about India, India generated 82.1 terawatt hour in 2023. Repeat, 82.1 terawatt hour. And if that is compared with the percentage of India's electricity generation, that is around 4.43 percentage. And this is being generated. So if we talk about the usage, it is 1395 kilowatt hour per capita in India. That is actually an average value. So that much of capacity is being used per day in India. So we want to talk about the ranking. India is fourth in the world for wind power capacity, and the first obviously goes for the China. And when we talk, we do have some statistical reports with the graphs that are here. So while I was talking about the types of turbines, that is offshore turbines and onshore turbines, globally, we do have offshore turbines in few places. As you look into the graph, there is a vast difference between onshore wind turbines and offshore wind turbines, because setting up a wind turbine on the surface of water is a bit risky. And even if you set up a wind turbine on the water successfully, that is like a person without knowing the swimming standing on the surface of water. Anytime it may be collapsed, because ocean is purely unpredictable source that can turn into anything. So customers do not prefer offshore turbines generally. That is the reason we do have very small amount of turbines on the surface of water, but then we do have many turbines on the onshore. So in 2012, when we look into the data, we are somewhere around 250 or 275,000 megawatt. But then in the decade, that is 2023, within 10 years, we have reached around 10 lakh turbine. And if you see the percentage of offshore turbine that is being increasing year by year, that is, customers also do invest on the offshore turbines. If we talk about India alone, like how does it participate in the contribution? Here it is. If we talk about 2012, we were around 17,000 or 18,000 megawatt. But then when it comes to 2023, it is somewhere around 43,000. This is what the growth looks like in the wind energy sector. Wind turbines participate a major role as solar panels do. These are the two major sources of renewable energy that are being used globally, and they do majorly contribute towards a vast level in renewable energy sector. And whilst we were talking about India, we do have plants that are set up in many states. So if you want to talk about the rankings that which state comes forward, we have this stat. We have Gujarat on the first place, contributing 12,209 megawatt of power. And we have Tamil Nadu, that is 11,042 megawatt. And then Karnataka, we do have 6,500 megawatt. And when we look into the graph that is on the right side, we have 102 power projects completely in active projects that I'm referring to. There are many ongoing or pipeline projects also, but then 102 active projects in India. If you want to check the source, I have given the link right below there. You can always check the source and study more about that if you need more information. That would be even more interesting. Being said all this, let's talk about career pathways. If a person wants to opt for a job in the wind energy sector, what are the ways that he can? If at all I wanted to enter into the wind energy sector or wind turbine sector or a renewable energy sector, what options do I have? We mainly have three options. That is manufacturing phase, project development, and operations and maintenance. If you come into manufacturing phase, there is always a big scope for research and development. Even though a wind turbine is successful or a wind turbine design is successful, there is a big R&D going on behind to make even more sustainable, even more efficiency. And you do have general manufacturing jobs in manufacturing phases where you have the pre-planned document and just need to manufacturing blades as per customer's requirement. And if we talk about occupations in project development, we do have land acquisition, asset management and logistics, and construction occupation and project managers. These all comes in the field operations where a turbine should be maintained in the site or a turbine should be repaired, many things. And occupations in operations and maintenance, that's where we are in. And you have service technicians, inspection analysts, and inspection engineers where a turbine gets inspected. So the next thing is reuse. Yes, a turbine would last for 25 years to 30 years, but then what happens to a turbine after that? we are not reusing for now. Maybe a wind turbine is being used for tar roads. They are being reused for that particular purpose. But a wind turbine or a wind blade is not being reused for the same purpose that is again installed in a new tower or new wind turbine. But we have a company called Siemens Gamesa where they have introduced a blade that can be recycled because they need to contribute to the zero waste turbines by 2040. Even many customers are planning for that, and as I said, there is a big R&D working behind, because you invest such a big amount, 20 to 30 crores, and being put in a bin for just 20 years is is not okay. So they wanted something that they can reuse, and that's where Siemens Gamesa comes in. They have created a recycle blade. I mean, I could say the world's first recyclable blade. They use new types of resin that can be separated from the other components of the blade, allowing the materials to be reused for new applications. That is, a blade can be refurbished or renewed to install it in the new wind turbine. This is still being in R&D and not yet proven. Maybe by, as Siemens Gamesa states, that by 2040 this can be followed up, and again, many amount can be saved, many money can be saved. Investments is such a big thing in industry that can be saved with that. And the next thing is disadvantages of wind turbines. Rather than disadvantages, as I am being in that field, I would not call it as disadvantages. I would rather tell them challenges. Here are the challenges. Wind power must compete with other low cost energy sources. That is, as I said you earlier, setting up a wind turbine is very costly, wherein you can put a panel, I mean solar panel plant very easily with lesser amount than the wind turbine. And if at all you get a damaged solar panel, you can change it with minimum amount. But then setting up a wind turbine is very costly. Even though after setting up a wind turbine, if at all it collapses, again a huge loss, you need to invest it again. That is the reason wind power must compete with other low cost energy. And second thing is, ideal wind sites are often in remote locations. It is a positive note as compared with residentials, because wind turbine produce loud noises. It cannot be set up near the residential areas. It is have to be set out of the residential area, that is remote location. That is a positive thing. But we have a negative for that. If at all a turbine is damaged or a blade is damaged, you need to have a crane that goes to the remote location and repair is done there. You know, there is 10 lakhs spent only for the crane to go from the sector to the site, only to crane go to the site and stand there, because all these wind turbines are placed in such a remote locations. They are being used high efficiently, and getting a crane to the site and being repaired is very, very difficult. And as I said earlier, turbines produce loud noises also. Next thing is, wind plants can impact local welfare. As being said, they are being set up in remote locations that directly, the other option goes for the forest area or the vast land area where you have natural habitat there. If you want to set up a 50 turbines or 25 turbines or 30 turbines, you need to disturb their habitat. And yes, even though if you want to repair a blade turbine, you need to get the crane to that habitat, and that is a disturbance for them. And large land area, if you want to set up a wind site, you need very, very large land area. And the last thing is high maintenance. After complete successful setup, also for the maintenance of a wind turbine, you need to pay a lot to maintain it. That is, if you get a crack, for repairing a crack is very, very costly than you set up a blade in the site. I hope these are clear. Thank you. I think I've finished up and conveyed everything. So I'm open to questions from the audience.
Sir, hello.
Hello.
Sir.
Yes.
Sir, actually, we need to first measure air wind flowing speed for a particular installation of wind generator. No, that is the first
Exactly.
basic step.
Exactly.
Correct, no, sir?
If a
Sir.
customer wants to set up a plant, for example, if he wants to set up a plant in Bangalore, assuming, not exactly, if you want to set up a plant in Bangalore, he needs to decide the location first. That is, in which location he can set up a wind turbine so that he can use that wind turbine very efficiently. That is without any disturbance. And we do have many engineers for that, where they go to the site and inspect the wind reports and wind stats and give it to the customer, and they even tell the number of turbines that can be placed on the site. For example, an engineer to the site goes and inspect, and he tells to the customer that this site can be fixed with 15 to 20 turbines. That is the limit. You know, just because you have the land, you can't fill up with the turbines. There should be
Yes,
a
sir.
minimum distance between one turbine to the other turbine.
How much distance, sir?
Uh, that is around 100 to 150 meters.
Okay, sir.
And again, it depends on the length of the blade also. That I mentioned for the 48 meters blade. So if you go for the 62 meters blade or 77 meters blade or the longest blade that is 131 meters, the distance even more further.
Sir, good evening, sir.
Yeah.
What should be the minimum wind velocity required, sir?
Sorry?
What should be the minimum wind velocity required to install a wind turbine?
Minimum wind velocity, I exactly don't have the number for that. I would check on that and get back to you.
Okay. And one more thing, sir. Actually, two types of wind turbine you told, onshore and offshore.
Yeah.
Among which one is actually more efficient, sir?
See, there are two options. One is high efficient with less risk.
Yes, sir.
Okay, so if high efficient with less risk, I would go for onshore. That is a turbine on the land. If I want another option that is high efficiency with high
Yes, sir.
risk,
Okay, sir.
I would go for an offshore
Ah,
turbine, because offshore turbine, that is a turbine placed on the surface of water, will be having high winds. Usually oceans will be having high wind, but then
yes, sir.
the chances of getting collapsed blade is very, very high, because you don't have a
Okay, sir.
stable foundation there. So a
Yes,
customer, it's like a knife hanging on the head of a customer. Anytime it might get
yes.
collapsed.
Okay, sir.
So,
Thank you so much.
so if concluding with an answer, high efficiency without considering the risk, that would be offshore turbines. You have the high efficient there.
Offshore turbine.
Yeah.
Okay, sir. Thank you so much, sir.
Yeah. Thank you. I hope you received many interesting facts from this particular topic. So expecting a lot. Questions? Any more?
Gautam sir, thank you so much for your great presentation. So they are very interactive. So thank you so much. And dear participants, please think over for the
Sir,
yeah. Punita madam, you can unmute madam if you want to ask any questions.
Is there any questions?
Yeah, Gautam sir, let's go ahead with the photo session. So
Sure.
dear participants, please join for the photo session. You please unshare your slides. Sir.
Sorry, 1 second.
No problem. Yeah. Yeah, dear participants, please on camera. Savita madam, please switch on your camera, madam. Yes. Gautam sir, please switch on.
1 second. I'm being restricted with the video. Give me a moment. I'll join in the phone.
Sure.
Mm,
Dear participants, meanwhile, you please think of some questions, and otherwise you can put it in the chat window. We will continue with Gautam sir once photo session has been completed.
yeah.
நீ பேச சொல்லுது பாரு.
Sir, you're on mute.
Yeah. We are a big group, so I request every one of you please turn on your camera and please stay back for just 30 seconds also, so that I can capture the photos.
Is there any other questions from the audience?
Yeah, if you have any questions, you can ask. Sir Gautam sir, if you can open your camera, we will take the photo, sir.
It is already on. I've been connected through my mobile.
Okay, but it's not coming. Did you put any name for that?
Yeah, same. My name. It will be Gautam Ramesh.
Okay, but it's not.
Hello, sir. Hello, sir.
Hello.
So myself, Dr. Mojna from Davangere.
Yes.
So in your presentation, you mentioned offshore and onshore.
Yeah.
So is there any power electronics issues? The difference in power electronics components in onshore and offshore?
Sorry,
Come
difference.
to the converters technologies. Normally, we are using huge converter techniques in windmills.
Exactly.
Is there any changes, difference between onshore and offshore windmills?
See, for example, if you consider a wind turbine on land, a substation would be placed around 20 meters or 30 meters distance. In case if you take offshore turbine, a turbine would be placed very far from the shore. And as I said you earlier, the substation should be kept out of water. So the only problem that you have is you need to transport the electricity from the turbine to the substation and then to the grid and to the user. The challenge that is faced in offshore turbine is transporting that electricity through cables from turbine to substation. That is the only difference.
Okay, I think in offshore windmills, I think they are preferring DC transmissions links.
Could be, it depends on the substation. But
Depends.
yeah, substation should be away from the water, that is off the shore.
Okay. What happens in offshore windmills? There a lot of research is going on MMC.
Yeah.
Material converters. So the further reason I asking, because in MMC they are preferring DC links.
Exactly. As I told you, there are many R&D that is going in the behind phase.
Sir, pardon, sir. So your voice is not audible.
Am I audible now?
Oh, yes, yes, sir. Now audible.
Yes, what was your question?
So in offshores, the lot of research is going on MMC, and they are preferring DC links. I'm talking about that.
Exactly. There is many research and development that is carried forward for the offshore turbines because
Yeah.
customers are reached the saturation point on the onshore turbines. So next
Ah.
thing that is being unexplored is offshore turbines. As I told you, there is many high risk being a setup, being a wind turbine setup on the surface of water. So in tact of challenging that risk, many research and development are going still till date to face that, so that many customers can rely on offshore turbines as they are giving a very high efficiency.
Oh, yes. Yes, thank you, sir.
Participants, please ask the questions if you have any, because it's a very different area. Because wind energy systems till now, many resource persons are spoken about solar only, but this is the different area, wind energy systems. So Gautam sir, thank you so much. You have given a great insights of how we can utilize this. So how to enter the wind energy fields also. So thank you so much for your great.
Thank you. Hope my content was very useful for you
Yeah,
and it was very new for you. I hope you learned at least a point from my presentation. I'm
sure.
glad with that.
Yeah, definitely. So still participants, Sar is with us. If you have any more questions, you can ask, please.
Yes, sir. Hello, sir.
Yeah, Prashidhar, please.
Sir, actually, as we normal wind speed, for normal wind speed, with that minimum speed also minimum voltage which is required for our household appliances or maybe our single 1 BHK or 2 BHK house, is it that minimum very small area it can capture that much of wind turbines are not prepared sir, till now
Okay,
in the research
so
field?
so I did
Any maybe in that tower will be there, any big house will be there. In that, if you place a very smaller one, that is the minimum we can generate from that. It is not possible, sir.
see. That's a complete valid point, and I missed to cover that point in the R&D. There is a R&D that is working on where you can set up a wind turbine on the terrace of your house. But then that is theoretically. If we talk about practically, I would give you two options. One is setting up a panel on the roof of your house. That doesn't require any eligibility criteria for that. You just need the sunlight. But the second option would be, I would give you a small scale wind turbine that you can set up on the surface, I mean terrace of your house. But then I give you the eligibility parameters. That is, for example, wind speed should be like this, and you're not supposed to set up a wind turbine with the residential area because it produces loud noise, and you have high maintenance. What would be your option? Which would you prefer?
Actually, sir, vertical turbines, that is actually that horizontal rotation, vertical rotation, different and 360-degree rotation as in a vertical formation. Different types of wind turbines are designed, no, sir, actually.
Exactly, there are many designs,
Uh,
but keeping the
Many
eligibility
designs.
criteria that wind turbine should contain, it is still in the R&D phase where you can set up a small scale wind turbine on the surface of your house. For example, if a solar panel breaks, you can modify or you can repair it, or you can even set up a new solar panel with just the amount of thousand. Okay, but then where if you set up a wind turbine and you find a crack or even a wind turbine collapses, you need to pay lakhs and lakhs of rupees to repair that or to replace that. So a big customer with big amount invest on wind turbines where he can manage that. For example, if I am setting a wind turbine on my surface, I need to put all my savings into one turbine and maintain it for the years. I just need to work for the maintenance itself.
Okay, sir. Okay, sir. Thank you, sir.
Yeah.
Savita madam? Savita madam?
Sir,
Yes.
hello, sir.
Yeah, Karibasura sir, please ask.
Sir, most of the wind turbines having 3 blades, sir. Is there any technical reason behind that? If we increase the number of blades, can the power output will be increased, sir?
No, there's nothing like that. Okay, so I'll tell you how a turbine starts. We have 3 blades that is positioned with 12 o'clock, 4 o'clock, and 8 o'clock.
Ah, right, sir.
When a 12 o'clock blade comes down, that
Right,
is
right.
towards the 4 o'clock,
Okay, sir.
the weight of the 12 o'clock blade itself takes the 8 o'clock blade to 12 o'clock. It
Okay.
actually works like a pendulum. We have a pendulum which goes like to and fro
Yes,
motion.
sir. Okay,
The
sir.
wind turbine usually works with that. A 12 o'clock blade comes down with a weight so that the 8 o'clock blade goes up to 12 o'clock. And this continues.
Sir, I thought actually probably if we increase the number of blades, okay, swept area will increase here. The output may increase, I thought.
We do have, I mean, we were having 4 blade turbines initially to,
Ah,
for example, if I do have some pictures, I'll look into it. If I have, I can show it for you. Um, One second. No, I don't have it for now. We
okay, sir.
were
No
having
problem.
four blade turbines initially, but then
Yes.
with the R&D, we found that if we remove one blade and keep this position, the efficiency
Ah,
of a wind turbine is increased much more because of this pendulum process.
okay, sir. Okay, sir. Okay, sir.
Yeah,
Thank you so much.
thank you. And I also forgot to mention another topic that we are working on our company is internal inspection. The analysis that we do perform is external inspection. That is, a customer comes to us, he gives the number of turbines, and he tells us to inspect the external analysis. That is a damage or a crack that is found externally. But then the project that we are working now currently is internal analysis. Internal analysis is something where a group of people from our company goes to the site, and from the foundation through the tower, he goes to the nacelle with the crawler, and from the nacelle he goes to the hub. He he places the crawler in the blade, and the crawler goes inside so that it captures the internal part of the blade from root to 40 meters, so that we can inspect the internal as well. So this is being followed in our company, and it is still in the baby process. Maybe down the lane in another 5-6 months, that would be in production.
Sir, on which weather condition it badly affects, sir? Wind turbines?
Maybe storm or even lightning damage. If you
Lightning.
go to if you go to US and UK, we have many
Hmm.
event inspection carry forward at this last 2 months. Event inspection is something like customer calls our company and tells, hey, this particular turbine is collapsed in my site, so we need to perform an event inspection. Event
Sir,
in, yeah.
one more clarification is this is some wind turbines fixed in Karnataka or Tirupati hill station. It is the cost is same what you were telling in America something crores together.
It depends.
Same cost, sir.
It depends on the length of the blade. The
Uh,
average cost would be around 15 to 30 crores. So if a blade is
uh,
around 48 meters, that would be around 15 crores or 16 crores. If it is around 62 meters blade, that would be around 20-25 crores.
Costly only, sir.
Yeah.
Then
You're not audible,
because
sir.
the
Sir, you're not audible.
Chalura sir, your signal is not proper. You can type in the chat window, sir.
what will be the response, sir? The
Sorry, sir.
voltage fluctuation. ಹೇಳು ಮಂಜು. ಇಲ್ವಾ?
Sir, I think you can drop a message with your doubt. I think your voice is not audible.
My doubt is that because of the wind, it will not be same speed. The voltage fluctuation will be there, sir.
Yeah.
What they do for to get the stable output, sir?
Exactly. There is no any stable output for that. If a turbine rotates faster, you can slow down with the brakes. We do have brakes for wind turbines.
Okay.
That is what
Okay.
we follow when we go for inspection and all. If we want to get the data, we apply brakes and we make that the turbine is stable position, and we extract the data, and then we remove the brakes. So if at all a turbine is increasing its speed than the limit, the technician will apply brakes so that it will get decreased. And the main problem that all the customers are facing is storage. There is no that vast amount of storage where the electricity amount can be stored. It can just be transformed and supplied to the user. So a big research and development is being carried forward in that sector as well to store a high amount of electricity.
And the people who are investing on these wind turbines are government sectors or only private sectors, sir? Mainly, I think, because of the cost.
I would say there are two people. One is private, and we do have hybrid where private sector collaborates with the government and they do invest on thing. In India, we do have that. It is tied up with the government as well. But a government alone, there is no any plan such that.
Thank you. Thank you very much, sir. You've given complete information about this one. Thank you, sir.
Thank you.
Savita madam? So dear participants, we have our fortune that we are with Gautam sir, because he is the special resource person from all our topics. And still, if you have any more doubts, you can put it in the chat window, or you can directly speak with Gautam sir. And every time we are telling the same thing. So this is the starting point, obviously. So I have already shared Gautam sir's phone number and email ID with you. So whenever anybody of your students or you want to continue with Gautam sir, maybe you want to continue with his company, or you want to go ahead with the wind energy companies, you just meet Gautam sir. I think I request Gautam sir, so kindly help us, sir, if anyone comes from this link. Maybe
sure, sir. You can always reach out to me if you have any doubts or if you are in any need. I'm always available.
Yeah, thank you, sir. Thank you so much. So dear participants, with this note, Gautam sir, thank you so much for immediately accepting our invitation and giving your vast experience with us, because we know something about solar, definitely, because maybe in any simple renewable energy courses we can come across solar many points, but we know hardly the parts of wind energy in our renewable energy courses. But even I thought that okay, the blades will be constructed at ground only and taken to up. But after your class only, I came to know that after installing this complete tower only, we will install that.
Exactly.
Yeah, it's very nice, sir. It's very nice, and your session is also very interactive. Thank you so much, sir, for your
glad you all liked it.
Evening time.
Sure.
So thank you so much, sir.
Thank you all.
Thank you, sir. Thank you so much.
Yeah.
Dear participants, kindly bear with us because this is the last but one day. So kindly bear with me, and please understand the test pattern. So tomorrow will be the test. So I will give you only 20 questions and you have to answer them from maybe 6:30. So 2 to 3:30 is one session. Tomorrow timings is different. I think you know this very well. You might have seen the schedule also. So the tomorrow timings is 2 to 3:30 is the first session. 3:30 to 5 o'clock is the second session. 5 to 6:30 is the third session. 6:30 to 7:30 is the time dedicated for feedback and also this one. This is the test. Okay. So half an hour test, 30 minutes. So I can hardly give 20 questions only. So you need to answer, at least you need to get 14 marks out of that. So as I already told you, we have done already one practice test of 15 marks. I mean 15 questions, and I will post, I have just prepared 15 questions from these slides up to today. And based on this, you will get 15 questions of, paper tonight. We just practice yourself. You will get answers also. I mean, once you have done the solutions. And tomorrow I will conduct the question. I will conduct the real examination and real test, maybe from ATAL portal only. So through ATAL portal, you have to go ahead. So we will take time, no issues, and we will settle down for some time and we will take time. So every one of you should attend tomorrow's test. Otherwise, we can't do anything. Okay. After that, don't blame me for any non-receiving of certificates, because they have clearly mentioned 6:30 to 7:30 is the time for test. Okay. And from my side, we can conduct 2 tests, practice tests. So you can prepare with them also. I have already shared PPTs also. So I feel it is very smooth sailing for you to easily get 15 or 16 or 17 marks. Okay. It's not a big deal. So please follow my advice and go ahead with this. And I really thank for this opportunity, because I have seen my old colleagues, new colleagues, old students, new students together. So I feel very much comfortable with this. So
Sir,
yes, sir. Sorry, I'm sorry. I'm sorry. Yes, sir.
sir, can I have a question?
Yeah, please.
I am Aditya De from Dream Institute of Technology, Kolkata, sir, Assistant Professor, Electrical Engineering Department. One query, sir. Tomorrow's test will be through ATAL portal, as you have mentioned. So we have to log in the ATAL portal, and there we will get the questions.
Yes, sir. Exactly correct. Exactly correct. I will be like this only, because everything should be recorded. I will be like this only. I will ask you to open ATAL portal only, and I will channelize to where it will be exactly, and I will guide you. Not an issue. Okay, sir.
Thank you, sir. Thank you, sir. Thank you very much.
Thank you, sir. Thank you so much. So, dear participants, still 15 minutes is left out. Shall we go ahead with LaTeX or shall we wind up? Are you ready to go ahead with LaTeX or shall we wind up? That's up to you. You please let me know.
We can go with LaTeX.
LaTeX, Amma. Okay, thank you. So let us go ahead with LaTeX only. So share screen. Yeah, let me go ahead with entire screen. Right. So I think my screen is visible. Overleaf. So from my side, actually,
also provide feedback link, sir.
Yeah, sure, madam. I will provide. So from my side, only paper means only 3 points are very much important. One is the table, and second one is the table, and the second one is figure, table, and equation. So how to do the equation? For example, as we know, the equation for average voltage and this one, what we can call average voltage and RMS voltage. So I will tell you these two only. So how to insert the equation, and then we will wind up. Okay, I don't take much time. Up to 9 o'clock only I will be here. So the average voltage formula is, yes, how to proceed. So here you have to write begin equation and end equation. So I will tell you how to proceed also. So we no need to do much, no need to worry much. So simply go ahead with equation editor in LaTeX. Anything is okay, this one or this one, anything is okay. So let me go ahead with the first one. Yes, so this is the equation. So V average, so let me have capital V, and average should be subscript. So C, everything is here only. So this is the subscript, okay, average. And you can see everything also, whether it is coming or not here, you can observe. So V average is equal to, so what is the formula? 1 by T. So let me take this type of thing. 1 divided by capital T, where capital T is the time period. 1 by T integral, two limits should be there for me. Integral 0 to capital T f of t dt. See, are you expecting in this way only or anything else? Okay, if I expect in this way only, then I can simply copy this. I can simply copy this and I can paste here only. Let me paste here, but before that we should get begin equation and end equation. Let me copy this and paste here. That's all. Everything will be automatic, so no need to worry. You can see, you can, something happened here. Yeah, there is a spelling mistake here. I'm sorry. Equation TION. That's all. I'm sorry. That's all. Let me recompile. See how nicely it has come with the number also. Okay, you can see the number. Okay, so this is the beauty of LaTeX. The numbering will be automatic. The numbering will be automatic. So no need to worry much. So this is the way of getting equations. So let me try with one more thing, RMS voltage. So how the RMS voltage will be. So let me go ahead with begin equation. Begin equation and end equation. And here it will be. So it should be RMS. Let me take subscript as RMS. It is, so what is the RMS? RMS is square root of, where is square root? Please search for square root. Where are you? Where are you? Yeah, this is the square root. Okay, root x. So square root of 1 by t. So here I need to write 1 by t. Square root of 1 by t. 1 by t. Integral 0 to t. So let me have integral 0 to t. F of t. See, here is a bracket. If I write f of t, it is f square of t. So superscript of 2 of t. Okay. If I write like this, f square of t will be outside the square root. So it should be inside. I am expecting this should be inside. So what shall I do? Shall I take this and put it within the curl braces? Then it will come. It's coming now. So this is the concept. So again, I'm sorry. F of t dt. Sorry, f square of t dt. Yeah, again it has been dropped out. Let me check. Let me put bracket here. Yeah, there is an error. Maybe I can remove this. That's it. So you can check this one. V RMS equal to square root of 1 by t integral 0 to t f square of t dt. Is it the way you want? Then take this. Copy this and paste here. That's all. That's also, this is the insertion of equation. So from my side, I feel very much comfortable. So I want to introduce you only three things. One is the figure, and second one is table, and third one is equations. That's all. Only three parts I want to introduce you. So with these 3 points and how to give sections, subsections, with this knowledge, you can write your own paper. Okay, and this is the one way, but this is simple understanding of LaTeX only, so nothing much in this, because every journal is having its own format and they will give you format only. Then you will bring your typed one, maybe in Word file you might have typed in whatever fashion you want, so without much concentration on the type setting. So you simply type something and please copy that one and paste here, then it will be very nice. Okay, so if you want me to show you something, I will show here. So same thing, if you same thing, okay, same file I am using. If you want to convert this into report class, you can simply type report. Okay, but report class should have at least one chapter, so remaining things may be sections, no problem. So let me write chapter here, and I have to give one name here. Let me write report class. Compile. So now see how it will come. Okay, report class means first page should be like this only title, author and date will be on the first page. Okay, second page onwards chapter 1 should come. Understood? If I want to go ahead with another chapter, for example, somewhere maybe after literature review, let me go ahead with another chapter, and this may be, let me have 2. Okay, recompile. Then it will come in the next page. See, it will come in the next page. Okay, so this is the beauty of report class. By using report class, we can write our thesis, dissertation, and even textbooks also. I have already shown you, I think. So I feel very happy with this textbook. Okay, with very less efforts only, I have made this beautiful textbook. You can see this. See how nicely it has come, just like a textbook only. Okay, so this is the beauty of LaTeX. Okay, this is the beauty of LaTeX from my side, from the bottom of my heart. Each faculty member should be trained on LaTeX, because LaTeX should be practiced, not trained. Because I feel there is no much information I can explain to you throughout days and days. Okay, much practice is required, that's all. No need to worry, it's very simple thing, but very helpful and very handy knowledge. Okay, and you can go ahead with resume also. I might have shown you resume also on that day. So this is resume. See, this much nicely we can go ahead with this. And I will show you something else also. So for example, if you want resume, you can go ahead here. Okay, templates are readily available. You don't need to worry much. Okay, open the templates. Which template you want? So many categories are there. For example, bibliographies and books. Okay, so many are there: journals, calendars, CVs, resumes, formal letters, assignments. So many are there. Posters can also be done here.
Sir.
Presentations. Yes, madam.
For presentation, suppose for PhD presentation or synopsis,
yes.
Which Beamer theme we should?
Yeah, very good, very good. I think you have some idea. So I will show you my presentation, madam. Okay. See, Beamer class itself is a presentation thing among. There is no need to go ahead with any other things. In that you can have the things. Okay, I will show you one of my presentations. Presentations, maybe Polytronics one. Yeah, this is the Beamer class. Okay, Beamer class itself is for presentation, so you no need to go ahead with anything. But the thing is, you can change different styles. So yeah, this is a well organized what we can call file. Okay, because everywhere I am commenting the things. You can just verify, everywhere I am commenting. This is the customized theme. Okay, this theme name is Ann Arbor. Ann Arbor means it is coming like this. That means top there are 2 colors, bottom there are 3 different colors. One color I can go ahead with the author name and phone number like that, and the title, short title I can go ahead, date I can go ahead, even day page numbers I can go ahead. Okay, this is the style, one type of styles. It is Ann Arbor style. So if you want me to show you what are the different styles available, I will show you. I will show you here different styles. Let me show you here. What is this actually? Themes. Yeah. We will go ahead with the same thing only. Themes and color themes of LaTeX Beamer. Beamer color theme. Oh, sorry. So no need to worry much, and just go every time go ahead with overleaf only. Overleaf can give so many things for us. Okay, it itself is a very big training. You can, it is a self mode training. Okay, you can utilize by yourself only. So many are there. Yeah. This is the combination. See, I will show you what I have used. I have used two things. One is the theme, and second one is color theme. So theme and color theme. I have used one theme and one color theme. I got this one. So what we can do much. So all these things are themes. Okay, maybe it will write here. See, themes are on rows. Okay, so this is one theme. Similarly, Ann Arbor is theme, Antibes is theme, and Bergen is theme, Berkeley is theme, Berlin is theme, okay, Bodlin is theme. Like this, so many themes are there. All row sides are themes, and column sides are color themes. For example, what I have used Ann Arbor, and the color theme what I have used is Wolverine. I have used Wolverine. So Wolverine, where is Wolverine? This is Wolverine. So I am using this theme. You can observe. Okay, I will simply zoom it if you can, if you want. Yeah, see, I have used this theme. If you can identify clearly. So top one is some two colors are there. Bottom three colors are there. Something like theme. The name will be coming here, and author names will be coming here. Okay. Now you can understand. If you don't want this, if you want this one, you can go back and you can change this the theme color. For example, I want to change color theme here, seahorse. Okay, let us see. Let me see how it will look like. This is Sea Harbor. What is this? Seahorse. So if you change this to seahorse, seahorse. So now you can see how it looks like. See, it looks like this. Okay, all these things are changed. So what is this blue color? This color is the background color. Okay, I have explained everything in this file. You can observe. Logo.
Sir, this reference is inside overleaf or in the Google search?
Which one, madam? This one, huh?
Sir, this one.
This one is inside overleaf only, madam. You can see. Okay, you can simply type. Themes and color themes of LaTeX Beamer. Okay, then it will come. Okay, this is inside overleaf only. Yeah, if you type in Google, it will come. It will come so many things. If you type overleaf also, then it will come immediately. Overleaf Beamer, what we can call themes. You can write. It will come.
Okay, sir. Thank you.
Yes, madam. It's a pleasure. So like this it will be, and see, I have nicely organized here. So for each command I have shown you. Even web links also, hyperlinks are also there. That means, for example, at the end, so I have given this lecture to one of the colleges. So at the end, yeah, these are the references. Okay. Here I don't use much. Yeah, see, this is the hyperlink actually. If you want to click this, if you click this one, you will redirect to YouTube. For example, if I'm clicking here, see, you can simply redirect to our lecture for the power electronics. Okay, so this is the way we can channelize. Even some other things. This is the NPTEL course link. If I click on this, it will go to NPTEL course link directly. Okay, so this is the way we can do it, and so many things also I know very little knowledge I know, because I don't invest much time on that. So whatever I require, I have done it. Actually, I have done my PhD from IIT Roorkee. In that time, I have done my presentation through LaTeX only. So at that time, whatever is required, I learned that one, and I'm continuing with that only. I don't learn much more than that. Okay, but a lot of scope is there to learn more and more. Okay, even background things, those things I have learned by myself only. I mean, after PhD or after IIT Roorkee only. Okay, like that, so many other things are there, very interesting things. So you can also learn the same thing. Okay, so I don't think that these things are there in LaTeX. Okay, these different things are there. Okay, new things are also coming in LaTeX. So I feel very much happy, such that we can also make use of them. Maybe poster we can make use of them. For posters, I'm struggling now. I'm struggling with Canva only. So whatever posters we have, I have only designed those posters. So if I know LaTeX also, so I can go ahead with LaTeX also. Okay. Yeah, with this I am trying to close this. If anyone wants more about LaTeX, you can contact me. I will give my contact details also. So thank you so much. Time is 9 o'clock. Even I am tired, and you people are also tired. So let's stop at this point. Savita madam, are you there?
Yes, sir. Yes, sir.
Yeah. Scholars, if you have participants, if you have any doubts, you can ask me, and I will share the this one also. I will share the what we can call that one, feedback form. I will share. Just
Sir, I already shared, sir.
you shared, madam.
Feedback already shared in the. Sir, I have shared the feedback, sir.
Which feedback? This session feedback is there, no? 10th one.
Yes, sir. I have shared already in the chat box.
10th also. Yeah.
Yes, sir.
Okay. Thank you, madam. Already 83 participants have been done the feedback. So I request remaining people to do the feedback, madam, please. Okay. And how many are presenting? Only 74 are there. Okay, fine. So see, today I have given all the insights. I will stop sharing this. Yeah, today I have given all the insights to you for regarding the test and certification. So please follow these things properly, then only you will get the certificate. This is true, because it is not conducted by me. It should be conducted by ATAL portal. Through ATAL portal only you have to go ahead. So my sincere request would be, everyone will be sincere. Tonight, maybe 9 o'clock, by 10 o'clock I will share the practice test. Okay, with 15 questions, and I have already done 15 questions, another practice test, that is 1 and this is 2. Please practice these things, and 3 things are missing. Okay, tomorrow's 3 things are there, so please go ahead with those things also, and please write the exam. Definitely some questions will come from tomorrow's sessions also, because I need to give justification to each and every resource person. Okay, so thank you so much for your kind cooperation, and for tomorrow some people should speak for the feedback session. Okay, you have to on your camera and you have to speak about the entire program. So my sincere request would be, please highlight some of the resource persons or some of the topics, and please look into overall picture. First open the schedule and please write something, prepare something, and you can speak that one. That would be better from my bottom of heart. Okay, so if you feel any, you need to give feedback on coordinators and resource persons and knowledge sharing and how it will be useful for you. So these things, on these points you can frame something from your bottom of heart and you can speak. Nothing wrong. Okay, so if you have any more doubts you can ask me now, otherwise we will wind up the session.
Thank you, sir. Thank you, sir.
Okay, thank you so much, dear participants, and we will meet tomorrow by 2 o'clock.
Okay.
Understood? No, tomorrow session will start by 2 o'clock only. By 1:45 I will be on. Okay, from 2 o'clock onward sessions will be started. Tomorrow there are 3 sessions. After 3 sessions only, examination will be there, feedback session will be there, then only we will move on to valedictory. Okay, 7:30 to 8 o'clock everyone will be present, please. Okay, so thank you so much, and I am winding up now. Savita madam, do you want to say